Good afternoon and welcome to Mrs. Spencer's Math Lab. It's good to be here another week. And if you are new one to the program, I need you to get pencil, paper, and be ready to get to work because this is not a lecture. This is something we do together. And if you're returning, you already know what to do. So be prepared to work today. Today is going to be a fun day because we're going to see if you are smarter than a fifth grader. So everything we do today is going to be based on the fifth grade curriculum in Virginia. And these are actual questions and problems and situations that I took off of the SOL program online. So when we get started, each time I want you to keep score, and we want to see if you're really smarter than a fifth grader. So let's get started. All right, the first thing I'm going to do is put up a number. And since you can't recite it to me, I want you to write the words for that number. That's number 1. Write that number in words. Write the words for that number as if you were reading it to me. Write the words for that number. That's easy, I'm sure, even for the fifth grader by now. 1, 2, 3, 4, 5, 6, 7, 8, 9. But that's not the way I want you to read it. I want you to read it as the number. And before we get started, I want you to say there are no ands in whole numbers. This is a whole number. So I'll get you started. Do not write the word and anywhere. All right, I'll pause a minute. I have enjoyed doing this. And as a result, I have some students that I tutor privately every week. And it's really been a great experience for me. I've gotten a lot of messages from parents and mostly parents who are happy that I'm doing this because now some of them have said now they know how to better help their children. When school opens, there are particular areas that you want me to take up on Tuesdays. I will be happy to do so if you will let me know. Because I know as you work with your children, things are so different and so many things have been moved down to the elementary school so much earlier than when I came along and certainly when you parents came along. All right, 1, 2, 3, 4, 5, 6, 7, 8, 9. What did you write? Well, I hope you wrote 100 23 million 400 56 thousand 789. This filled up the whole board, didn't it? Okay, 123,456,789. No and should be written anywhere. Now, how do we do that? Well, we learned the place value chart. The first 3 digits, 7, 8, 9, in the ones family. And we just know this is the ones family. The next 3 digits, 4, 5, 6, they're in the thousands family. So it's 456 of those. And the next family is in the million That's these 1, 2, 3 in the millions family. So when we read a number, and this is for the young people who are looking, we say the number, the comma, we say the family. So 123,456,789. All right, that was easy, so I hope you did that well. 123,456,789. All right, so I'm going to turn it over. And this time, I want you not to read this. You may need to read it, but I want you to look at this number, and I want you to tell me 2 things about this number. You notice I have the 6 underlined, and I have that underlined because that's the digit we're going to talk about in this number. All right, and what I want you to do is tell me the place that the 6 is in and the value of the 6. Now, so that we're all on the same page, place is a word and value is a number. And I'm going to wait a moment until you figure that out. Place is a word and value is a number. Okay, so for the place, I expect you to write words, and for the value, I expect you to write numbers. Okay, so I think you should have had enough time. So again, we go back to our place value chart. We have the ones family, ones, tens, hundreds. We have the thousands family, thousands, 10,000, 100,000s. We have the millions family, 4 million, 2, 10 millions, and 100 millions. And this then is in billions place. All right, did you get that? So what is the value of a 6 in billions place? Well, it's 6 billion. So we have a 6 and 9 zeros. 3, 4, 6, 7, 8, 9. And that's the value of the 6 in billions place. All right? Sometimes students get confused and you say, what's the place? And they tell you the value. And you ask the value and they tell you the place. So I always, to differentiate between the two, I said place is a word and value is a number. So let's remember that. So we can say what place any number up here is. If I want to know what the 5 is, I have to find the place and then I will know the value. And one easy way to do this, I noticed that the only non-digit digit I wrote was 6, and I replaced everything else with zeros. So that should not be difficult as well. All right, let's move. We have one more with numbers. And remember, this is 5th grade. This is 5th grade. And if we want to be billionaires, we got to know how to count it. We got to know how to write it. All right. This next one says 70 million. And I want you to tell me, what place will the 7 be in the number 70 million? Remember, these are all examples that I didn't make them up. I got them off of the 5th grade practice worksheets that students have. And some of these I have helped some of the students I tutor to do. 70 million. What place is the 7 in? Place is a word. So remember that. Place is a word and value is a number. And so many students have trouble with that. Okay, so you need to write 70 million. So that's 70 All right, and what place is it in? Let's see. Ones, tens, hundreds, thousands, 10,000s, 100,000s, millions, 10 millions. So your answer should have been 10 millions. All right, so this is the answer I was looking for, not this. If you wrote this, that's not the answer to the problem. I asked for the place. This is the number. This is the value. All right. Hope you're following me. Again, this is from grade 5. These are the kind of questions they ask. Now, this is an interesting one, I thought. And this, you're going to create a number from these directions. These are the numbers, and these are the places. Write the number. Create the number. Write the number that these directions give you. And let's see what you come up with. Write the number that these directions. There's a 5 in millions place, an 8 in ones place, a 6 in 100,000s place, a 2 in thousands place, 3 in billions place, a 1 in tens place, 7 in millions place, and all the empty spaces, put zeros. This is interesting. I thought this was a cute one, but not necessarily easy for a 5th grader, but I'm sure they were able to do it. All right, let's see what you're going to do with this number. Now, all of us should get the same number with these same directions. All right, and of course, by now you know your place value up to billions when you get to the 5th grade. And usually we stop at billions. We go to the billions family. And then from then on, when we write larger numbers, we use what we call scientific notation. And that comes along too in the elementary school, but not in the 5th grade. 5 millions, 8 ones, 600,000s, 2 thousands, 3 billions, 1 10 in the tens place, and 7 in the millions place, and all the other places are zeros. Okay, I wish I could see what you're writing, but I can't. So we'll say how we'll do this. Again, it's important that you know your place value. It's important that you know your place value. So I'm going to have, I know I'm going up to billions, so I'm going to have, let's see if I can push this up a little. Okay, so what I would do is I would make some little blanks for each number, each space that I need. So I got ones, tens, hundreds, thousands, 10,000s, 100,000s, millions, 10 millions, 100 millions, billions. So I know I've got to, because I know place value, I know I've got to have that many digits in this number. I don't know how I would have done it if I had to start with millions, because that's jumping around, because they're not in any order. If they were in order, it would be easy. All right, so we just fill in each one. The 5 in the millions place, so that means this is a 5. An 8 in ones place, here's an 8. A 6 in 100,000s, okay. Okay. Okay, I'm just making sure I'm going along. All right, 2 in thousands place. A 3 in billions place. A 1 in tens place. A 7 in millions place. All right, so I got this 5 in the wrong place. A 7 in millions place. And a 0 in all the places. Let's see, the 5 is in. Oh, well, okay. Here's what I did. let me correct this. In writing it, okay. In writing it, let's see, that's number. Okay. Okay, 5 in millions. Okay. Oh, I left off a 7 in millions. All right. Let's start this again. Let's start this again. I'm trying to see what I left off. I think I left off one. Let me find it. A 5 in millions. 7. Oh, I left off at 7. A 7 in 100 millions. All right. 7 in 100 millions. A 5 in millions. Okay. Let's see what else. A 6 in 100,000s. Okay, and 2 in thousands. Okay, and a 3 in billions. Okay, a 1 in tens. And 8 in ones. And where did I leave off? 7 in millions. Okay. I see I didn't copy this correctly. All right, let's do the one that's, I'm going to change something here so we'll do this a different way, because I didn't copy this quite right, and that's why, because I have 2 in millions place. All right, the 7 should be in, let's see, 100 millions. So, okay, I'm going to put 100. Okay, and I left off 1. So let's just do this one. Okay, so we're up to billions, so we got ones, tens, hundreds, comma, thousands, 10,000s, 100,000s, comma, millions, 10 millions, 100 millions, comma, billions. All right, so let's 5 in millions. Okay, 8 in ones. Okay, 6 in 100,000s. 2 in thousands. 3 in billions. 1 in tens. 7 in 100 millions. And a 0 in all the other places. So we have to have a 0 here. And a 0 here. And a 0 here. All right, and the number is 3,705,602,018. All right, we finally got it there. I had left out 1, and then I had 2 millions, so we couldn't work it that way. All right, but this is interesting, and it's a nice little activity. Certainly checking to see if you know your place value. And place value is very important because we use this in various ways as we work with any kind of number system. We have to know the place values of the numbers. All right, check your answers, see if you're doing correctly. I guess that one I'll have to eliminate because I did not write it correctly. So let's go to the next one. All right, this one says find the product. And a product, and we use vocabulary in math. It does not necessarily use symbolism all the time, but we have to learn the vocabulary. So it says find the product. Find the product. Okay. And they want you to do it in expanded form. All right. So now you may find the product, but this time you're told how we want you to do it. Expanded form. Okay. And I'm not going to say anything. I'm going to see if you remember what that means. All right. And the number is 351 times 4. That's the product. 351 times 4. All right, and we want it in expanded form. Okay. So you can use your calculator, but you can't just put 351 and multiply it by 4, because I want it in expanded form. So you have to expand this number 351. So again, here we come with place value. We have to know what the 3 is, what the 5 is, and what the 1 is. And I'm going to be quiet a moment and see if you can do this in expanded form. Expanded form. And that means we understand the value of each digit in our numbers that we are multiplying. And these are challenges that fourth graders have, and parents have when they're trying to teach them at home as well. That's why I'm doing this as I go, because these are things that parents need to understand to help their children as they go through this math virtually. Okay, so we're going to expand 351. 3 represents 300. Okay. All right, plus 5 tens, which is 50, plus 1. Okay. So that's the expanded form. So we're going to have to multiply each of these by 4. All right. And 4 times 300 is 1,200. 4 times 50 is 200. And 4 times 1 is 4. Add those together, and what do we get? 1,404. Okay. 1,404. Did you get that? I'm sure you could have multiplied it without doing the expanded form, but this is one of the methods they use. And they also use box multiplication, which again is a part similar to expanded form. And many parents are saying they never heard of box multiplication. I never heard of it either. But somebody came up with that idea. I can't say that that's easier than this method. And certainly it's not easier for those of us of old school from just going ahead and multiplying each digit. All right, so keep your score now. Keep your score. Now, if you got the right answer but you didn't do expanded form, it doesn't count. All right? You have to follow directions. You have to follow directions in math. I hope I'm not erasing too quickly, but I want to go ahead and see if we can get through all of these. All right, here's a word problem, and they have a lot of word problems. All right, it says, okay, this is number 6. Okay. All right, this is about 2 girls, Anna and Sarah, who are going door to door selling Girl Scout cookies. And Anna earns $2 every door she goes to. She gets $2. But Sarah seems to get $5. So Sarah is doing a little better. The question is, now I want you to write down, Anna earns $2 per door. And Sarah, $5. And the question is, what is the smallest earnings that both will have in common? What is the smallest earnings that both will have in common? What is the smallest earnings that both will have in common? All right, so I'm going to give you a moment to think about that. Anna gets $2 per door. Sarah gets $5 per door. And what is the smallest earning that would be the same for both of those? And of course, you can almost figure that out by just looking at it. All right, I'll pause a moment. And how many of you figured out that what we're really finding is the least common multiple? And this is an application. And they didn't ask the student to find the least common multiple, but the student had to know that that's what you're looking for. So what we're really looking for is the least common multiple of 2 and 5. All right, least common multiple of 2 and 5. Multiples are the numbers we get when we multiply 2 or 5 and 5, each one by another number. So we start with 1 times 2, 1 times 2, 2 times 2, 3 times 2, 4 times 2, 5 times 2, and so on. And we don't have to stop, okay. Okay, so that's what we're really doing. So for 2, we're going to get 2, 4, 6, 8, 10, 12. Now find the multiples of 5. All right. And so the multiples of 5, 1 times 5, 2 times 5, and 3 times 5, and so on. Okay, 1 times 5 is 5. 2 5s, 10. 3 5s, 15. So let's just look at these numbers. And I'm going to erase some of this so it doesn't look so jumbled up. I erased the last one, that was 10. All right, and for 5, we have 5, 10, and 15. I stopped because I'm aware that both of them have 10. So the answer is $10. The smallest amount that both of them will have received that is common to both of them is $10. Anna, of course, has to go to how many doors to get that? She has to go to 5 doors. 1, 2, 3, 4, 5. When Sarah only has to go to 2 doors to get that amount. All right, that's an application of finding the least common multiple of 2 numbers. All right. Are you smarter than a 5th grader? Were you able to come up with that before I discussed it? All right, let's go to number 7. Let's see. All right. And of course, this is a similar type problem. Jake makes $10 an hour. Judy makes $15 per hour. What is the smallest check they can receive so their earnings match? And so you have to be able to just look at that now, because this is another one that is applying the least common multiple. And what is the least common multiple of 10 and 15? All right. Least common multiple of 10 and 15. Now, these are questions I did not make them up. They came out of the SOL package. These are questions that students have. And they don't tell them to just find the least common multiple. They have to know when to apply it. And the SOLs have more application than they do just skills. But you must know the skills in order to do the applications. All right, the answer to this would be 30. $30 is the least amount that smallest check that they receive so that their earnings match. All right, the least common multiple of 10 and 15 is 30. So it would be $30 is the answer for number 7. All right, let's move right on. We have a lot more to go, and I don't even think we're going to get to all of them. All right, I'm putting these numbers here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The first thing I want you to do is look at those numbers, and tell me which of those numbers are prime numbers. Which are prime numbers? So I hear somebody saying, I forgot what that is. What are prime numbers? All right, prime numbers are numbers. I'll wait a moment, see if you can tell me which are prime numbers. In this set of numbers, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Which of these numbers are prime numbers? All right. Prime numbers then are 2, 3, 5, and 7. What do they all have in common? They have only themselves and 1 as factors. The only factors way we can get 2 by multiplication is 1 times 2, 1 times 3, 1 times 5, 1 times 7. Can you think of some others? What's the one after 10? 11 is 1. 13 is 1. 17 is 1. Now don't get mixed up and think they're all odd numbers. All odd numbers are not prime numbers. How do I know? Because number 9 isn't, for example, and it's odd. All right? The next set of numbers I want you to find are the composite numbers. Composite numbers, have you forgotten what they are? All right. Composite numbers. See if you can recall. All right. The composite numbers up here are 4, 6, 8, 9, and 10. Why are they composite numbers? Because they have factors other than themselves and 1. 4 is 2 times 2, 6 is 2 times 3, 8 is 4 times 2, and 8 times 1. Each one is 1 times itself, of course, and 9 is 3 times 3, 10 is 2 times 5. So if a number has any factors other than itself and 1, it's called composite. All right, let's see how we're doing. That's number 9. All right. The next set of numbers I want you to find in that group is the even numbers. And I'm sure you can do that. The even numbers. Even numbers. And of course we know what even, most people know what the even numbers and odd numbers are. All right, even numbers are numbers that are divisible by 2. So that's 2, 4, 6, 8, and 10. So actually, we can find them anywhere because any number that ends in 2, 4, 6, 8, or 0 are even numbers. Okay? Okay, and the last set, as you might guess, is the odd numbers. Find the odd numbers. So that's easy because we've already found the even numbers. Okay. So the odd numbers are what? 1, 3, 5, 7, and what? 9. All right, we see some of the odd numbers are also composite. All right, and we see that some of the odd numbers are also prime. All right, so sometimes you're given a list of numbers and you're asked to find all 4 of those, or how many of those properties do all the numbers have. Okay, notice 1 was not a prime number. Why? because the prime number is multiplied by itself and 1. But 1 is multiplied by its only itself. So that does not fall in that category. Okay, so much for that. Understanding our number system. And this was an interesting one I helped a student with last week. He got this triangle. All right. And so this is what they asked him. They said all they had up there was A, B, and C. They named the triangle by its vertices. And of course we know a triangle has 3 angles. And so there's an angle at A, an angle at B, and an angle at C. All right, we also know something else, which I'm going to not say because I want you to be able to answer this question without my telling you. What could angle A be? Which one of these values? Could it be 45 degrees? Could it be 90? And don't go by looks, because I'm going to ask you why. Could it be 100 degrees or could it be 120 degrees? So look at it for a moment. Because this was on one of my students' quiz, the homework activity last week. And of course, they didn't have a clue. Of course, they just didn't think about it. Didn't give you any numbers except for the answers. And said, I don't know how to begin. Okay, what did you think? And did you guess or do you have a reason? All right, the answer is A. It could be 45. It couldn't be 90. How do I know? It could not be 100. And it certainly couldn't be 120. How do I know? Because the angles of a triangle, the sum of the angles of a triangle is 180 degrees. So angle A plus angle B plus angle C for every triangle equals 180 degrees. I don't care how big it is. The sum of those angles is 180. Well, another thing we know, the angles and the sides are related. The angle opposite the longest side is the largest angle. So the largest angle is B. Okay? And C is the smallest because this is the shortest side. Okay? So A is somewhere in between. All right? So again, how do we know that 45 is the best answer? Well, it couldn't be 90 because we look at this one and this angle is greater than 90 degrees. So if I added 90 to something greater than 90, that's going to be more than 180. And so would the rest. So what did a student have to know? First of all, how the sides relate to the angles. And secondly, how many degrees are in the whole entire triangle. All right, I thought that was interesting and different. I don't think I ever had an example like that when I was in school. And here was another one. And I hope you can see it clearly enough. But it took me a moment to try to figure that out. So I'm going to see what you say. All right, here we have 4 squares. And the first square has 4. It's made up of 4, has an area of 4 squares. The second square has an area of 9 squares, and so on. And my question to you, how many squares would be in the one that would be number 8? And believe me, this was asked of a student last week as I tutored them. And so I said I was going to certainly share that with you to see if you could figure it out. Okay, what do you think would be the number of squares? What is the number of squares? And if I kept on going, did 5, 6, 7, and 8. what would be the number of squares? We have 4 squares here, 9 here, 16, and 25. Okay, we have 4 here, we have 9, we have 16, and 25. What do you think it would be for 8, number 8? If we kept on going, drawing these squares until we got to number 8, how many would 8 have? So I had to look at that a while myself. Has anyone figured it out? I wonder if you have. Put some numbers up on the screen and let me know. What would number 8? What would number 8 be? What would number 5 be? What would number 6 be? What would number 7 be? And then what would number 8 be? So I looked at this for a while. And I noticed that this is number 1. But this is a 2 by 2 square. This is number 2. And this is a 3 by 3 square. This is number 3. But this is a 4 by 4 square. In other words, 4 square has also each side is equal. All right, and this is number 4, and it's a 5 by 5 square. So if it's 8, it must be a 9 by 9 square. And so 9 times 9 is 81. Number 8 would have 81 squares. Did you figure that out? But they had to look at this pattern on the 5th grade level and figure that out. I hope you were able to do that because you are smarter than a 5th grader. Okay, now I have some little word problems that I'm going to share with you. All right, a violin costs $4,000. The cost of the violin is $4,254. But if you buy it on sale, you get 65% off. Well, it's a nice sale. 65% off. And the question is, how much would you save by buying it on sale? How much would you save by buying it on sale? How much would you save by buying the violin on sale rather than buying it for its real original cost? All right. I'll wait a moment. 65% off. And the cost was originally $4,254. And violins are expensive. I had a daughter who's played violin, and she was about ready to go to the full violin, and she lost interest. I certainly wasn't going to put out that money for the full violin, and she not continue. So I have had experience with buying violins. They are expensive, but the music is beautiful. Okay, you should be finished. All right, so what we're doing then is finding 65% of $4,254. All right, 65% of, okay. Did you use your calculator? I didn't tell you you could, but when you could do it 2 ways. You could do it $4,254. And you could find 65% of that. So you write 0.65 and multiply. The other method that you could have used was to use the proportion which says 65 over 100 equals X over 4,254. Either one of those methods would give you the correct result. You know, here you just multiply Here you cross multiply and you get 100x equals 65 times that. All right, and so what did you get? Did you get $2,765? $2,765.10. That's how much you would save by buying it on sale. And we are all shoppers. We certainly need to know how to work out those savings for ourselves. We ought to know. We are not dependent on the clerk in the store to tell us how much we're going to get back. We certainly should be able to figure that out for ourselves. All right, either one of those methods would have given you that answer. All right, here's another problem, and I'm rushing now because I'm looking at the time, and the time is going pretty fast. And ask yourself as we go along, am I smarter than a fifth grader? All right, how many problems must Joe do correctly if he had 70 problems? And he's trying to get 90%. Trying to make a 90. All right, again, that's finding the percent of 70. And you could use either of those methods that I just gave you. And these numbers are rounded ones. I rounded them off so that it wouldn't take long. So you should have found that he needed to do 63 problems. And certainly if you're in school, you ought to be able to sort of keep all your grades and sort of figure out your own grades or your tests. You know how many problems you're sure of, and you can come away knowing I got at least 90%, or I got at least 95%, got at least 80%, and so on. So we learn to figure out those things out just by finding percentages. All right, I'm going right on. Are you smarter than a fifth grader? All right, here's a restaurant. It's selling cheeseburgers. Okay, and the ratio of cheeseburgers to chicken sandwiches to chicken sandwiches is, all right, that's the ratio of cheeseburgers to chicken sandwiches that they sell. That's that each day they seem in one day. This seems to be the ratio of cheeseburgers to chicken sandwiches that they sell. All right, they have to sort of look at these things because they know how to order. They don't just go to the store and say, give me a box of this and a box of that. They have to figure these things out mathematically. Even to mixing candies. They don't just throw some peanuts in with something else, because they're going to add this stuff together so that it comes out the right price and they are not losing money. So all these things are done mathematically. All right, so the question is, if they sell 12 chicken sandwiches, so they sold 12 chicken sandwiches. All right, I'm just gonna write S-A-N-D. We know that's sandwiches. I want to know how many cheeseburgers did they sell on that day. All right, the ratio of cheeseburgers to chicken sandwiches that they sell each day is 7-2. They sold 12 chicken sandwiches on a particular day. How many cheeseburgers did they sell if this is the ratio? All right, I'll pause a moment, and our time is getting less and less. Okay, the ratio of cheeseburgers to chicken sandwiches is 7-2. So that means for every 7 cheeseburgers, they only sell 2 chicken sandwiches. Or for every 2 chicken sandwiches, they sell 7 cheeseburgers. All right, but the ratio has to be written. The first mentioned is first, and the second mentioned is second. And if we were writing it as a fraction, it would be 7/2. All right, so they sold 12 chicken sandwiches. How many cheeseburgers did they sell that same day? So they sold 6. So they have to do 6 here. So 6 times 7 is 42. The answer is 42. All right, working with ratios. All right, remember with fractions, if you multiply one number by a number, then you must do that to the numerator. And even if we did it without the fractions, if this becomes 12, and this is 6 times 2, then this will become 42. Either way you look at it, the answer is 42. All right, so that's one, the use of ratios. All right. All right, let's see, we don't have much time. All right, they work with area and perimeter as well. If we're working with perimeter, if suppose we want to put some trim around our kitchen, and how would we figure? What would we find to find out how much trim we needed around our kitchen? And that would be the perimeter, because we need to go all around all the walls and that we're going to put the trim on. What would we find? We're trying to find how much carpet we needed on the floor. That would be what? Area. All right, I'm not going to put those problems up because it probably takes too long. All right, here's this little one that I thought was cute, dealing with combinations. An ice cream store had vanilla ice cream, had strawberry, and they had chocolate. Those are the 3 flavors, main flavors. All right, and they had 2 kinds of cones. They had the sugar cones, and they had the cake cones. All right, and the question is, how many combinations could they make out of this situation? How many combinations? Okay, they had vanilla, strawberry, chocolate, ice cream, and they had sugar cones and cake cones. So how many possible combinations are there with this setup? And I chose an easy one for you, but there are some others that have 3 and 4 things, and that's even a little more. All right, let's think about it. The vanilla could go to a sugar cone or a cake cone. The strawberry could go to a sugar cone or a cake cone. And the chocolate could go to a sugar cone or a cake cone. All right, so that's what? 6. Well, the way we could have done it, we have 3 flavors and 2 cones, and 3 times 2 equals 6. So those are 6 combinations. All right, and of course sometimes you have problems like so many color trousers and so many color shirts. And how many of us ever stop and look in our wardrobe and say, how many combinations? I got so many skirts, so many blouses, so many sweaters. And if you stop to ever really realize, you'd have a lot of combinations that you probably never put together because you never even think of it that way. Okay, our time is getting short, but I want to ask you, are you smarter than a 5th grader? These are some of the kinds of problems that fifth graders are having. And as I said before, very seldom do they just ask them to multiply something. It's usually in a situation. So parents and students, you must be able to read math. Learn to read. Now notice as I read any problem that I did not already put up there, as soon as I read something, I started writing. You don't read a math problem as if it's an English paragraph, because you will never learn how to work a problem that way. Soon as you get to something of mathematical consequence, you need to jot it down. I do that, and I'm the teacher. So certainly you should do that as a student. Again, are you smarter than a fifth grader? Somebody who's not even in the fifth grade may be smarter than a fifth grader. Congratulations to you. Parents, some of these things I know you have forgotten. But when you have a fifth grader, you're going to have to do these things with your fifth grader. So I want to say thank you for being with us tonight and asking yourself the question that I ask you. Am I smarter than a fifth grader? Thanks for coming in today, and I'll see you next week.